Greetings, fellow mechas. Today, we're going to be going over the quotient rule. The quotient rule is as follows. If f and g are differentiable at x, and g of x does not equal to 0, then the derivative of f divided by g at x exists, and d of dx of f of x divided by g of x is equal to g of x times f prime of x minus f of x times g prime of x divided by g of x squared. Now this is just a quick rule, or like a way of remembering the quotient rule is by saying low, so a low term or g of x, then you take the derivative of the high term of f of x, so low d high, minus high, you take your numerator term or f of x, and then you take times it by the d low, you take the derivative of the g of x, or low term or denominator, then we square the bottom, and away we go. Then we're all set up and ready to go and solve the problem. That's just another way of remembering the quotient rule. Now, we're going to be using the quotient rule in the following problem. The problem. In part A, find the derivative of x squared plus 3x plus 4 divided by x squared minus 1. And in part B, find the derivative of e to the negative x. Alright, now pause this video, take a few minutes, and solve this problem. Welcome back. Hopefully you were able to solve this problem. Now let's work on it together. So in part A, we need to find the derivative of x squared plus 3x plus 4 divided by x squared minus 1. So if we're using our quotient rule, well, as the quotient rule states, we take g of x, so x squared minus 1, and we go times it by the derivative of our numerator, f prime of x, so that's going to be 2x plus 3, and we're going to subtract it from f of x, or our numerator, which is x squared plus 3x plus 4, then we're going to times it by our g of x prime, so our denominator prime with the first derivative of our denominator, which is going to be 2x. Then we're going to divide this whole numerator by our denominator squared. So x squared minus 1 squared. Now let's simplify. So let's first expand our numerator and let's see what we get. So let's see. We get 2x to the third plus 3x squared minus 2x minus 3, and then we get minus, remember this negative sign out in front, we get 2x to the third plus 6x squared plus 8x And now remember this is a negative, so let's just change our signs real quick. So we get -2, negative, negative. There we go. All right. So what can we cancel? Let's do this. And then we have x squared minus 1 in our denominator still. And now let's simplify it down some more after we expand it out. So what can we cancel? Well, with the 2x to the thirds, they cancel out. And anything else cancels? Let's see. Nope, that's it. So we get, this is going to be equal to minus 3x squared minus 10x minus 3. And then our denominator is still going to be x squared minus 1 squared. And this is our simplified derivative for part A. And that is the solution for part A. I don't believe we can simplify it anymore, so we'll leave it at that. So for part A, our solution for the derivative of x squared plus 3x plus 4 divided by x squared minus 1 is equal to negative 3x squared minus 10x minus 3 divided by x squared minus 1 to the second whole squared. Now in part B, we need to find the derivative of e to the negative x. So what is e to the negative x? Well, this is equal to 1 over e to the x. So our f of x is 1 and our g of x is e to the x. So if we apply the quotient rule, well, it's going to be low, so e of x, then we take the derivative of 1, which is just going to be 0 minus 1, low d high minus high, so 1 times the derivative of e of x, which is just e to the x, then we divide it by e to the x squared. So what do we get? Well, e to the x times 0 is going to be equal to 0, and then we get 1 times e to the x, but we have a minus, so we get negative. This is equal to negative e to the x divided by e to the x squared. Well, what can we do from here? Well, since we using exponent laws, we can cancel one of our e of x's, since we have 2 on the denominator and 1 on the numerator. Therefore, this is going to be equal to negative 1 divided by e to the x. Or we can rewrite it as negative e to the negative x. If we bring e to x to the numerator, this is what it would look like as well. But both ways are fine, and they both are solutions to the problem. And that is the solution for the derivative of e to the negative x is going to be negative e to the negative x. I hope this video helped. If it did, please consider subscribing and liking this video. Thank you.